Let's do practice problem number 5. It's on page 188. And I'll read the problem. It says, use Newton's thought experiment on the motion of satellites to solve the following. A, calculate the speed that a satellite shot from the cannon must have in order to orbit the Earth 150 kilometers above its surface. B, how long in seconds and minutes would it take for the satellite to complete one orbit and return to the cannon? So let's work it. So I set it up already with given, find, and solve here. So here's the Earth. Here's the satellite in orbit around the Earth. Here's our height above it, 150 kilometers. And we want to know what should be our orbital velocity and what should the period be in minutes and seconds. But if you left it in seconds, I don't really care. So let's do this. For A, the orbital velocity equation is this. The orbital velocity is equal to g times the mass of the Earth. Oh, I didn't put the mass of the Earth up there. You guys didn't ask me for it. Is that okay? Did you know it? No, I feel terrible. I don't feel that terrible. You should have asked me for it. And I'd have said, "Oh, I'm sorry," and I would have given it to you. What I just did is called blaming the victim, but I'm the teacher. It's okay. Now, so this is G, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared, times the mass of the Earth. Oh, I'm off screen. Let's zoom out. And everybody knows this anyway. It's common knowledge that the mass of the Earth is 5.97 times 10 to the 24 kilograms. 0.98. Okay, we'll use 0.98. Okay, I don't care. It's no, don't worry about it. All right, and then what is R? Well, R is the radius of the Earth plus our height above the Earth, which is 6.37 times 10 to the 6 meters. Plus, now you have to change this, 150,000 meters. And, well, if you do that, the 1.5 here just adds to the 3.7. So this is going to be 6.52 times 10 to the 6 meters. You can plug that in your calculator and verify that. But did you all agree with that? Okay, good. And so now when you plug that into your calculator, let's see what we get. Let's turn the thing on here. And let's see, it's the square root of parentheses. You got to use parentheses a lot. 6.67 times 10 to the negative 11 times 5.98 or 5.97, I don't care, times 10 to the 24 kilograms divided by 6.52 times 10 to the 6, close parentheses, so it all gets square rooted, and you get, all right, hold on. Okay, 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24 divided by and then 7.821, right? 7.8 or 7.82 times 10 to the 3 meters per second. Or if you wrote 7,821, right, I'll give it to you. But you really shouldn't have more than 3 significant figures with your answer, so I'm writing it in scientific notation. Now, for part B, we want the period in minutes. And the way I like to do the period, I mean, there's that, the period squared is equal to all that stuff times the radius cubed, and you take the square root of something cubed, and it gets really complicated. I just like to use, well, we know that the orbital velocity is equal to 2 pi r over the period. So the period is equal to 2 pi r over the orbital velocity. So that's going to be 2 times pi times r, which is 6.52 times 10 to the 6 meters. Now you can make a mistake here if you accidentally use just the radius of the Earth. You have to do the radius of your orbit, which is a little bit farther out, 150 kilometers above. And then we're going to divide it by 7.82 times 10 to the 3 meters per second. So let's see what we get. Let's see. And times 2 times pi. Does this have pi on it? This is not my calculator, so oh, there's pi. Oh, crud. All right, 2 times 3.14159, that's close enough, to pi times 6.52 times 10 to the 6 divided by 7.82 times 10 to the 3 equals, did you get 5,238 seconds? Or 39 seconds? Or 5,240 seconds. That would be better. Now I'll accept that as your answer, but what if we wanted it in minutes and seconds? Because I don't really have a feeling for how long that many seconds is. So let's divide it by 60. And let's see, divided by 60, and you get 87. Now you could put 0.31 minutes, but it said minutes and seconds, didn't it? This is not 87 minutes and 31 seconds. This is 0.31 of a minute. So 0.31 of a minute is the same as 0.31 of 60 seconds. So 0.31 times 60 seconds is 19 seconds. So you could say, well, 87 minutes and 19 seconds. I don't really care about that. So if you wrote this, that's good. If you wrote 87 minutes and 31 seconds, I'm going to take off 0.31 points. Okay? Because that's just not right, you know. I can only give you credit for things that are right. So let's zoom out and take a look at the whole thing. Now, are there any questions on this problem? Yes?
For A, I got 7,815.
Yeah. That rounds off to this. 7,815 is 7.82 times 10 to the 3. Yeah. And if you used, 0.97 here instead of 98, I don't know. I've looked it up in different places, and some books say 5.98, some say 5.97. Doesn't really matter. It's only off by the difference of a few trillion, kilograms. That's negligible compared to the mass of the Earth. Any other questions? That is all.